Have you ever stopped to wonder what the speed of progress actually looks like? I mean, we talk all the time about AI getting smarter, but what about it getting faster? Like fundamentally faster? Today, we're going to look at a piece of tech that doesn't just break the speed limits, it rips them up and builds a whole new kind of highway. 130 terabytes per second. Just kind of let that number sit there for a second. It's a flood of data that's almost impossible to really picture. But what if I told you that wasn't the data for a whole country's network, or even an entire continent's, but for one single piece of hardware? Okay, so let's try to wrap our heads around this. At its busiest, the entire global internet, every Netflix show, every tweet, every single Google search happening at once, moves around 112 terabytes per second. And the tech we're talking about today has more bandwidth than all of that combined. This isn't just about being fast. This is, well, it's a totally new scale of computing. All right, so this absolute monster of a technology, it has a name. It's called the NVLink Spine. It's a revolutionary new interconnect fabric from NVIDIA. And believe me, it is absolutely set to change the entire game for the architecture of AI. So what is this thing, really? Well, at its heart, it's this incredibly dense mesh of cables that links together dozens of GPUs. But here's the magic. It's way more than just a bunch of wires. It allows up to 72 of these powerful GPUs to act as one, like a single unified brain. The best way to picture it, really, is as the nervous system for a supercomputer, letting all the parts talk to each other instantly. But let's be real. You don't build something this ridiculously powerful just for fun. There had to be a massive problem that needed solving. The NVLink Spine was basically born out of necessity. It was designed to smash through a wall that was holding back the entire world of AI. Which brings us right to the big question, doesn't it? Why? Why on earth would you need to engineer something that's literally faster than the entire internet? What kind of problem is so huge that it demands a solution this extreme? Well, for years, the problem was basically a giant digital traffic jam. As AI models got bigger and smarter, the connections between the GPUs doing all the work, the older stuff like PCI and InfiniBand, they just couldn't keep pace. It was like having a city full of geniuses, but connecting all their offices with slow, single-lane country roads. You had Ferraris stuck in bumper-to-bumper traffic. That was the reality, and it put a hard cap on how far we could push AI. And wow, just look at this. This chart shows you just how insane the jump is. This isn't a small step up, it's a total demolition of the old way of doing things. The NVLink Spine doesn't just give you a wider road, it's like it replaces the road with a teleporter. And that right there, that's the whole ballgame. This is what it's all about. This insane level of bandwidth and instant communication, it's the key that finally unlocks the door to the next frontier. Trillion parameter AI models. We're talking about models so huge, so mind-bogglingly complex, that just a few years ago, they were pure science fiction. Now they're actually possible. But okay, hold on, because the story gets even bigger. We need to zoom out a little bit, because this isn't just about one amazing piece of hardware from one company. This technology is actually the keystone of a huge strategic pivot for the entire industry, a move away from closed-off walled gardens and towards what people are calling AI factories. So, right alongside the spine, NVIDIA dropped another bombshell, something called NVLink Fusion. And this is huge. They're basically opening up their secret sauce, their core connection technology. It's like they built the world's best engine, and now they're giving the blueprints to other companies so they can build their own custom cars around. So the blueprint is actually pretty simple, but it's brilliant. Step 1, NVIDIA opens up its core tech. Step 2, all these other major players jump in and bring their own expertise. And step 3, the result? You get this explosion of new, modular, custom-built AI systems that can be tailored for any job you can imagine. And we're not talking about small companies here. Look at this. This is a who's who of heavy hitters in the tech industry. We've got Qualcomm, Fujitsu, MediaTek, Marvell. They're all getting on board.
This isn't just a friendly handshake, it's a full-blown alliance to build the next generation of AI infrastructure together.
Forbes really hit the nail on the head when they described this. They called it a strategic shift towards modular, heterogeneous AI compute factories. Now, that sounds complicated, but all it really means is that the age of one-size-fits-all computing is over. We're now in the era of build-your-own supercomputer. So, you put all of this together, this mind-bending speed, this new open ecosystem, and you have to ask the big one, the ultimate question. Are we literally paving the physical road to artificial general intelligence right now? Is this the stuff that makes it truly possible? I mean, you can draw a straight line, right? That seamless connection between all those GPUs. Well, that's the kind of massive unified thinking power that AGI would almost certainly need. And those trillion parameter models this unlocks. That's how you get the deep, real-time understanding of context that we associate with actual intelligence. The whole thing just lines up. Okay, but let's be super, super clear about something. This technology is not AGI. It isn't a thinking machine. But it might just be the most critical piece of the puzzle we've ever seen. It's the foundation. It's the essential backbone that takes the dream of AGI and makes it feel like a real engineering problem we can actually solve.
So at the end of the day, that nervous system analogy really is the perfect way to get it. The NVLink Spine is the high-speed network that will let the AI giants of the future think, not as a bunch of separate computers talking to each other, but as one single, coherent mind.
And that's really where I want to leave you. We're building the nervous system at a scale that's almost impossible to comprehend. So the big question isn't just, can we do it anymore? The real question is, what kind of mind are we going to build with it?